In the part B, how we worked out the time period of this wave, and from the time period, how we worked out the frequency. We know the frequency is a reciprocal of the time period. So what we did using a CRO, cathode ray oscilloscope, first we work out the time period. Time period is a time to complete one oscillation. So one complete crest and a trough, that is one oscillation. In one oscillation completed in how many boxes? One, two, three, four boxes. So each box stands for 0.2. So that's why it is 0.2 multiplied by 4. But that is 0.2 millisecond. So we wrote 0.2 milliseconds or 0.2 exponent negative 3 into 4. So from where this 4 came, it's the number of the boxes it covered. That's why it will be 0.8 into 10 to the power minus 3. That is the time period of the oscillation. But we need the frequency. The frequency is a reciprocal of the time period. So we can take 0.8 exponent negative 3. So that was giving us 1250 hertz. That is the frequency of this wave. In the next part, two sources S1 and S2 of a sound waves are positioned as shown. The sources emit coherent sound wave. When we say it's a coherent, it means a constant phase relation is there of a wavelength 0.85 meters. The sound detector is moved parallel to the line S1 and S2. As you can see, we moved the sound detector here from a point X to a point Y. So we start from here and we reach till Y. An alternate position of a maximum loudness L and a minimum loudness Q are detected, as illustrated in figure 5.2 I mean. Distance S1 to X is equal to distance S2 to X. So X is like a central maxima. This distance S2Y is 7.4 meters. These two distances are equal. When two distances are equal and the two waves are highly coherent, what will be the part difference? The part difference will be zero wavelength. When the part difference is a zero wavelength, what kind of interference they will we'll observe? We'll observe a constructive interference. In a constructive interference, two waves enhance the effect of each other. That's why we'll observe a loud sound. Then the second one, there's a quiet sound. What is the reason for the quiet sound? Then what happened? The part difference has changed to half wavelength. When a part difference is a half wavelength, we'll observe a minima, and that's why we observe a quiet sound. They cancel out the effect of each other. Then another maxima is there. When we have another maxima, the first maxima after the central, so what will be the part difference here? The part difference will be equals to lambda. And if the part difference is one wavelength, again a constructive interference, a loud sound will be observed. Then as we further move down, there is a minima destructive interference happen or occur. The two waves will cancel out the effect of each other. And what will be the part difference? In this case, the part difference will be 3/2 lambda. So destructive interference. When the part difference is lambda by 2, 3/2 lambda, 5/2 lambda, 7/2 lambda, they cancel out the effect of each other. And the last one, the interference pattern when we observe, there's a loud. So what is the part difference here? The part difference is actually equals to two wavelengths, and this constructive interference happen or occur. That is why these patterns are changing. And same thing, if we move up, we will also observe a pattern of a quiet and a loud sound, loudness or a sound changes to maximas and the minimas as the part difference will change. The question is, what is meant by a coherent wave? It's a very like repeated definition in exam. So try to learn, whenever there's a definition, try to learn the standard answer. Don't try to write answer in your own words. Try to learn a standard definition. So a coherent wave means that there's a constant phase difference between the two waves, we call them as a coherent wave. State the phase difference between the 2 points of a wave arriving at minima closer to x. So whenever there's a part difference is there, like when there's a when we talk about, this is about the part difference. But what about this is the part difference of the waves. But what about the phase difference? The phase difference of the wave, they cancel out the effect of each other. Here, the phase difference will be 0, or you can say 360. This will be 180. Again, phase difference we say 0, 180, then again it will be 0 in terms of the degrees. In terms of the radian, it will be pi radian if it is a destructive. So they ask, state the phase difference between the two waves arriving at position in the minima. So the phase difference will be 180. It's already degrees marked. So 180. Determine the distance S1y. So how we can determine the distance S1 and y? From S2y and S1y, when we take a difference, like from S1y minus S2y will be the part difference. And what is this part difference? This part difference is equals to two wavelengths. How I worked out two wavelengths, as I just mentioned a pattern, one wavelength, half wavelength, like zero wavelength, half wavelength, 1.5, and then two wavelength. So at point Y, when S1 will move to Y and S2 to move to Y, the difference in their lengths is equals to twice the wavelength. So we need S1Y minus S2, this is 7.4 meter, to the wavelength of a wave, it uses 0.85. So this is equals to 0.85. It's subtracted, other side it will be added. So S1Y will be equals to 2 times 0.85, which is 1.7 plus 7.4 is there. So we got the sum here, which is 9.1 meter. That's a distance from S1Y. Is it clear discussion? That how we worked out the distance? If let's say this was the same question, but they slightly changed the question and now they're asking that now this is a point Y. Let's say they said this is a point Y. How to do this question? You will use the same manner, but now the part difference will be changed. So from S1Y minus S2Y will be equals to what? It will be equals to 3 wavelength by 2. Because it's a destructive interference and it's a second destructive interference. So the part difference will be 1.5 wavelength or 3 by 2. And then we'll just substitute the values and get the value for any one of the unknown. So what you're equating with depend on the position at which you're comparing the pattern. If I'm comparing a pattern at position X, the part difference will be 0. Like in that case, I will write S1Y minus S2Y will be equals to 0. Or I can say S1Y is equals to S2Y. Like both will have the same distances. So it's very important that which position you're equating or comparing the results. So this was page 20 from the topic waves.